Greetings, my wonderful students. I, Dr. Jyoti Vaipavi, welcome you to today's lecture video. Today we are going to learn about very important concept, that is bipolar limb leads, Einthoven's triangle, Einthoven's law, and triaxial system. So we shall learn today mainly about ECG leads. Okay. So let's understand what is a lead. Often students get confused between electrodes and leads. Electrodes are just metal plates, okay? Whereas ECG lead is actually a pair of electrodes with a set of wires connected to a ECG machine and one on one side, and the electrodes are placed on the body surface. Okay, this forms the ECG leads. So purpose of this lead is to record the electrical activity of the heart. Okay, so when we say this is how the ECG lead means, and you should remember that the ECG works on volume conductor principle. This we had discussed in the very first beginning. You remember that? Yeah. ECG works on volume conductor principle. The primary source of current is the heart. It produces electrical currents when it is undergoing depolarization or repolarization. We know that. And when it is undergoing that, the electrical current are conducted through the body fluids and body tissues. They are called as volume conductors. Okay. And electrodes, when you place electrodes on the body surface, then these electric currents are picked up by the electrodes and we get a ECG, electrocardiogram, on the ECG machine. So this is the principle. This is the experiment to show that whenever there is electrical activity in a piece of cardiac tissue placed in a body fluid like salt solution, when you place the electrodes, it can record a activity. Okay, this in detail we have studied. So just to remind you that the ECG works on volume conductor principle and the electrodes are picking up this electrical activity. Okay, so electrodes, when I tell electrodes, you should be thinking, how does it look like? It looks like this. Okay, there are two types, reusable and disposable. Reusable looks like this and disposable looks like this. Okay, according to your convenience, you can use whichever you want. So what is the axis of the ECG lead? Axis of the ECG lead is nothing but an imaginary line. There is no line here. We have just put the electrodes connected to the ECG machine via wires. But this line, what we are seeing here, is an imaginary line drawn from the negative electrode to the positive electrode. This is called as the axis of the lead. Okay, that is the direction. And how are we going to draw this line? By the direction from negative electrode to positive electrode. This is called as axis of the lead. In upcoming lectures, we shall also come across many axes like mean QRS axis, depolarization axis, different types of axes you will be hearing and learning. And when I say lead axis or axis of the lead, you shouldn't get confused. It's just an imaginary line drawn from negative to positive electrode. Okay, this is called as the axis of the lead. Okay, now we have understood what is the ECG lead and what is the axis of the lead. Let's now learn what are the types of ECG leads. In present scenario, 12 standard ECG leads are used to record the voltages from the heart. The ECG leads are broadly classified into limb leads and chest leads. When electrodes are placed on the limbs like right arm, right leg, left leg, it's called as limb leads. And when the electrodes are applied on the chest, it is called as the chest leads. Limb leads are further classified into bipolar and unipolar leads. Okay, bipolar limb leads are lead 1, 2 and 3, and unipolar limb leads are AVR, AVL and AVF. What are all these things? I'll be explaining. Chest leads, you are classified as unipolar chest leads, and they are V1, 2, 3, 4, 5, 6. So there are 12 ECG leads. So in present day, we use 12 standard ECG leads to record the ECG. Now, as a good student, you should be asking me, why you need 12 leads? Isn't one lead enough to record ECG activity? Why should we have so many leads? That's my question. Well, well, what is this? This picture is Barcelona's home football stadium. So, what is this doing over here? Okay, let me explain why have I put this picture over here. Football is the most watched and most popular sport in the world, as we all know that, with around 3.5 billion fans across the world. So whenever a major football event is happening, fans across the world brave the elements against all the odds to watch the football event and come over here. But some of them cannot make it to the stadium. So what about those fans? How do they watch the match? What do you do? Thanks to advent of technology. So the event of the football is recorded by many types of cameras. This is just a camera plan to show any football match. So they use around 37 cameras. Can you imagine? Is placed around the stadium. Okay, so there are all kinds of sophisticated cameras, right from the drones, helicopter camera, handheld camera, and many types of cameras which I don't know, but all the different types of cameras are used so that each and every aspect of the match is recorded and telecasted to the fans across the world. Okay, so now we understand how one event is taking place and so many different cameras are recording so that we don't miss any part of the live event, so that a person who is sitting at the comfort of his home can watch his match just like as is watching in the stadium. So when I come to this 12 lead ECGs, also is doing the same thing. Taking an ECG is just like recording a football event, like a very big football match, with array of different video cameras. So each lead records different angle. Okay, so we have placed so many leads so that we can record the electrical activity of the heart from almost all the angles across 360 degrees. So that's why we use 12 leads of ECGs to record the electrical activity of the heart. We need multiple cameras, multiple leads to record it. I hope you understood the analogy. Okay, coming to frontal plane and horizontal plane. Okay, when you take a cross section of the heart, the frontal plane of the heart records the frontal cross sectional view of the heart, whereas the horizontal plane, this is the horizontal plane, records the horizontal plane of the heart. Okay, frontal plane provides a cross sectional view of the frontal view of the heart. Horizontal plane records the horizontal plane of the heart. Okay, and we already know that there are limb leads and chest leads. So limb leads, there are lead 1, 2, 3, AVR, AVF, AVL. These are called as frontal plane limb leads or just limb leads. They record the frontal cross-sectional area of the heart. Horizontal limb leads are V1 to V6. They are also called as chest leads, and they record the horizontal cross-sectional view of the heart. Can you see? It is recording like this, and this is just recording the frontal plane. Okay, so I hope you understood this, and that's why we use a lot of leads, around 12 leads, to record both the frontal as well as the horizontal plane. So with this basic knowledge, let's now learn what is the term bipolar means. That the electrocardiogram is recorded from two electrodes, and it is recorded bipolar because it's recorded from two electrodes, two poles. Limb leads because the electrodes are placed on the limbs. Okay. Thus, a bipolar lead is not a single wire connecting from the body, but a combination of two wires, and their electrodes are placed on the limbs and they record the electrical activity of the heart. So, today we'll learn uh, what are bipolar limb leads and how they were placed and why is it called as standard limb leads. Okay. So, this whole thing about bipolar limb leads will be useless if I don't mention about William Einthoven. Okay, William Einthoven, um, he was a very great physiologist. He served as a professor of physiology from 1886 till his death. Okay, from the age of 26 years until he died, he was teaching as a physiology professor in University of Leiden. um, Around in 1900, you imagine it is 120 years ago, he devised the first string galvanometer known as the Einthoven galvanometer. With this instrument, he was able to measure the changes of electrical potentials caused by heart muscle, and he recorded graphically all these changes happening in the heart, and he coined the term ECG, that is electrocardiogram, for this also. And the names of the waves PQRST is also coined by Einthoven. So he did a lot of work on the ECG. So Einthoven continued to develop electrode arrangements. So he started placing electrodes in different parts of the body and started recording the electrical activity. So when he was doing this, he standardized. He came up across this lead 1, 2, and 3, and he called them as the standard limb leads. So for this amazing stupendous work, he was awarded Nobel Prize in the year 1924. Just Nobel Prize in Physiology or Medicine was given in 1924, just 3 years prior to his death. Okay, so with this, giving credit to this amazing person. So let's see this picture. So this is the picture showing a ECG taken by Einthoven for the very first time, and you can see this man, and this is the whole setup of the ECG machine they had used, and you can see this jars. He's keeping his legs and hands in these jars. So this legs and jars is nothing but the electrodes. They used them as the electrodes. These jars were filled with salt solution and they were connected all around. He got a ECG recording. How amazing, isn't it? Look at the way we have come from there to the digital ECG machines today. But still, the principle remains the same. The working of the galvanometer remains the same. Everything is same, except for the instrument has become more sophisticated. But the basic thing what we learn today about the bipolar limb leads is exactly same how it used to work in those days, 120 years ago. Okay, so there is, as we have learned, bipolar limb leads, there are three types: ECG lead 1, lead 2, and lead 3, right? Einthoven just applied the combination of electrodes conventionally. He started applying and trying to find out what he can record, and he just conventionally applied these electrodes. Okay, the bipolar leads were so named historically because they record the difference in the electrical voltage between two extremities or two poles. Okay, bipolar, the difference between the electrical activity between these two is recorded. That's why it's called as bipolar limb leads. Okay, let's now learn how Einthoven made lead 1. Okay, so what he did in recording the limb lead 1, he applied negative terminal of the ECG is connected to the right arm here. Okay, and the positive terminal is applied onto the left arm here. Okay, so what happens when the ECG records? Now I have applied this. What happens when ECG is put on and I record? The left arm electrode detects some electrical activity. Okay, it is seeing, it is the exploring electrode. Positive electrodes are exploring. It detects the activity um, electrical voltages variation in the heart, and it is transmitted to the left arm, right? And right arm detects the voltages transmitted to the right, right? Nothing's very simple. So it is also detecting electrical voltage, this is also detecting. Okay, and now inside ECG what happens, the right arm voltages are subtracted from the left arm voltages, and the difference appears as lead 1. So the potential of lead 1, what happens to the lead 1 when I apply the electrical electrodes like this is that whatever the exploring electrode is, that the potential is there, that is recorded minus of the negative electrode. Okay, and that's how ECG machine computes it and gives us the potential of the lead 1. Okay, very simple. It's just conventionally he applied that, and he made sure that when he recorded he got certain positive waves. So that is how the ECG lead 1 was made. Okay, okay, moving on to lead 2. To record lead 2, the negative terminal of the ECG is connected to the right arm, like that, like lead 1 only, but positive terminal is applied to the left leg now. So when he did this, so what happens, the right arm is negative with respect to left leg. The electrocardiograph records positively, that is lead 2 records the difference between left leg minus RA, because this is the exploring electrodes, V minus. So that is how the ECG machine computes and calibrates. Okay, so whatever the electrical activity this and this is picked up, the potential of lead 2 is given by this formula according to the combination set up by the Einthoven. Okay, positive minus negative electrode. Then coming to lead 3. To record the lead limb 3, the negative terminal is now applied to the left arm and positive applied to the left leg. This means that electrocardiograph records positively when the left arm is negative with respect to left leg, right? Lead 3 records the difference between left leg and left arm. So it's given by this formula. I hope this is clear. Why he said these combinations, why this was called as lead 1, 2, 3 as the standard limb leads, because he was trying to get positive waves in whichever combination of positive negative electrodes he was putting, and finally he got this lead 1, 2, 3, and he got positive waves in all the 3 leads, and this is how Einthoven historically said that this was the standardized bipolar limb leads. Okay, so now Einthoven's triangle. Now we have learned what is lead 1, now we have learned what is lead 2, and now we have learned lead 3. What is triangle now? So what did Einthoven do? He put all the leads together, the axis of the leads together. Lead 1, okay, negative and positive here. Let's put lead 2. He put lead 2, negative and positive here, and we put lead 3. Okay, so when he put all the leads together, it formed a imaginary triangle, okay, which he called it as Einthoven's triangle. Okay, so when he put all the leads together, it made a triangle. Okay, actually when you draw it properly, so the center of this triangle should be the heart, and this is in the frontal plane. This is the Einthoven triangle. So he named it as Einthoven triangle when he put all the leads together with the center as the heart. He named as the Einthoven's triangle, right, with the center as the heart. Very simple. Now let's the lead 1, 2, 3 can be schematically represented as triangle now. That is called as Einthoven's triangle. We know that. It shows this triangle shows the spatial orientation of the 3 standard limb leads. As you can see, lead 1 points horizontally, right? Horizontally, its left pole is positive, and right pole is negative. Therefore, lead 1 is given by the formula La minus Ra. Okay. And when you come to the lead 2, it points diagonally downwards. Its lower pole is positive, whereas the upper pole is negative, right? And it is given by the formula LL minus RA. Simple. Now let's move on. Lead 3 also points diagonally downwards. Okay. Its lower pole is positive, whereas upper pole is negative. Okay. And lead 3 is given by the formula LL minus LA. Okay. Nothing, it's just putting all the leads together and putting the formula. Now Einthoven of course could have hooked the leads up differently, but he didn't do so. He has done in a certain way. He's arranged in such a way that he arranged all these things in such a way that um, these bipolar lanes, okay, when you add them together, when you add lead 1 with that of lead 2, okay, so lead 1 is given by La minus Ra and lead 3 is given by LL minus Ra. When I add the potential of these two, I get lead 2. When I add lead 1 plus lead 3, I get lead 2. Okay, as you can see here, the La, the left arm, is positive in the lead 1, right? Whereas it is negative in the lead 2. So when I add these two, okay, when I sum up these two, La is cancels out. So LL minus Ra is remaining. LL minus Ra is nothing but lead 2. So in other words, I can say that voltage of lead 1 plus voltage of lead 3 is equal to voltage of lead 2. Okay. So this is called as Einthoven's law. Okay. So Einthoven hooked up these leads in such a way that in any case, any given instance, lead 1 plus lead 3 should give you the lead 2. So ideally it should have been 1 plus 3 equals 4, but in ECG it is 1 plus 3 is 2. Okay. So this is called as Einthoven's triangle and this is called as Einthoven's law. Very easy, isn't it? It's nothing to worry. It's very easily Mr. Einthoven has done all this. Okay. Now that we have understood what is Einthoven's triangle and what is Einthoven's law, let's take an example and find out whether it is true or what. Okay. So let me state intervals in a different way. We know that lead 1 plus lead 3 is equal to 2. If I can state it, I'll state it in this way. So Einthoven's law states that if the electrical potentials of any two of the three bipolar ECG leads are known at any given instant, the third one can be determined by mathematically by simply summing the first two. Okay. If any two you know, obviously by putting this equation, you can find out the third one. That's all. However, when you are doing the summation, you should be very clear about what is positive and what is negative. Let's take this picture. Let's look into this picture and see the example. At this point, I might request you to grab a paper and a pen for this. Okay. So they have applied electrodes here, right arm, and left leg, right? These are the main electrodes I have applied. So when at the right arm, it is picking up minus 0.2 millivolts, okay, with respect to the average potential in the body. Left arm is plus 0.3 millivolts, whereas the left leg, it is plus 1.0 millivolts. Let me repeat it properly. The right arm is minus 0.2 millivolts, negative with respect to the average potential of the body. Left arm is plus 0.3 millivolts, which is positive, and left leg is 1 millivolts. Okay, now let's calculate what happens to lead 1. Lead 1 is given by left arm minus right arm, right? Left arm plus 0.3 minus of minus 0.2. We get plus 0.5. Okay. Lead 1 is La minus Ra. Okay. Lead 2. What happens to lead 2? Lead 2 is LL minus RA. 1 minus of minus 2, we get 1.2 millivolts. What is lead 3? Lead 3 is LL minus LA. So LL is 1 minus zero point 0.3 is plus 0.7 millivolts. So lead 2, lead 3, lead 1 we calculated. Now let's apply lead Einthoven's law and find out. So mathematically lead 1 is 0.5 millivolts, lead 3 is 0.7 millivolts, we get plus 0.2 millivolts. How amazing, isn't it? He from the scratch found out what is electrodes, he found out how galvanometer, Einthoven find out how galvanometer works, and he by permutation, combination, everything he did, and conventionally he put the electrodes in such a way that lead 1 plus lead 3 should give us lead 2. So this is why it is called as standardized limb leads. Even after 120 years, still we use the same principle, the same Einthoven's law, same lead 1 plus lead 3 is equal to lead 2 holds good even today. Okay, so that's about the Einthoven's triangle and Einthoven's law. Now, so Einthoven's triangle and triaxial diagram. So triaxial system is nothing but Einthoven's triangle which has been redrawn, rearranged. The same triangle I will rearrange. The Einthoven rearranged it. Okay. So what does lead 1 do? Lead 1 is recording the electrical activity of the heart. Where is the electrical heart placed? It is the center of the triangle. We know that. Einthoven triangle is nothing but the leads along which has the center as the heart. So lead 1's center point is the heart, right? What is lead 2 doing? This is also recording the electrical activity. So center point of the this triangle is heart. So lead 2 also has the center point as the heart. And lead 3 is also recording the electrical activity of the heart, which has heart as the center of this triangle. So lead 3's central point also is the heart, right? So what Einthoven did, he rearranged all these leads in such a way that the common point, that the heart is the common point for all the leads, isn't it? uh, all the leads should are rearranged in such a way that they intersect at the common point, that the heart. Are you getting me? He rearranged it in such a way that heart is here, right? I'll show you. So here is the heart. So he arranged just by sliding the lead 1 to the center, okay, and sliding the lead 2 to the center, and sliding lead 3 to the center, okay, so that the center point is the heart. So he made the triaxial system. This diagram is a very useful way of representing the three bipolar leads. It also helps us measure so many things, especially the mean QRS vector and mean QRS axis, which we will be discussing in the upcoming classes. So this is how Einthoven's triangle was rearranged in such a way that all the leads intersect at the common central point, the heart. Okay, so you should not get scared looking at this diagram. It is nothing but the Einthoven's triangle, just slided a little bit so that they all intersect at the heart. Let's see this again. So this is the Einthoven's triangle. So all of them have heart as the central point, and so to rearrange them in such a way that they intersect at the heart, the Einthoven just slided the lead 1 down, lead 2 to the rightwards, lead 2 rightwards, and lead 3 leftwards, and we got the triaxial diagram. Okay, so that's nothing, it's just the rearrangement of the Einthoven's triangle. Okay, so this is how a triaxial diagram looks like, the Einthoven triangle represented as a triaxial system. Okay, triaxial because there are three axes: lead 1 axis, lead 2, and lead 3. Okay, they are rearranged. The triangle is rearranged in such a way that it is intersecting at the center. Now, if I can put angles for this, if I can put a protector and show you, okay, you can see this diagram. So lead 1 is horizontal axis and it is representing the 0 degree. It is seeing the heart from the 0 degree. Okay, and lead 2 is seeing the heart from the 60 degree angle, and lead 3 is 120 degree angle. See, 0, 60 and 120. So with the help of bipolar Einthoven uh, leads, with the help of Einthoven triangle and triaxial system, we can study the electrical events of the heart through 0 to 120 degree. So it is covering from all these angles. We can see the electrical activity of the heart. Okay, so when we are putting a degrees over here, you should not get scared. It's just that the triaxial system we have put, and the orientation of each lead and each axis to the positive angles we have taken, and it is just 0 degree, 60 degree, and 120 degree. So that's about the Einthoven's triangle and triaxial system. And when you connect all these leads to the ECG machine, you get the readings like this. Lead 1 is looking like this, lead 2 and lead 3 looks like this. So normal ECG recorded from the three standard ECG bipolar limb leads look like this, because the recordings from all the bipolar limb leads are similar to one another. So these diagrams show recordings of the ECG in lead 1, 2 and 3. So it is obvious that the ECG in these three leads are similar to one another because they all record positive P waves, positive T waves, positive QRS complexes, because Einthoven had planned uh, and conventionally placed the electrode in such a way that in any of these three leads I get positive waves. That's why he got positive waves in all the three um, leads. Okay, on analysis of the three ECGs, it can be shown with the careful measurements and observations that Einthoven's law holds good for this. See how to calculate this. So what does Einthoven's law say? 1 plus 3 equals 2. So 1, if I can calculate, so how many boxes are there here? So this one big box is 5 plus 1, 6 boxes, 6 small boxes here. This QRS axis 5 plus 6, 7 boxes. 7 plus 6 is 13. Let's calculate this. 5, 10, 11, 12 and 13. Did you understand? So this is around 6 boxes, 6 small boxes tall. This is around 7 small boxes tall. So 7 plus 6, you'll get 13 small boxes tall. So ECG Einthoven's law holds good here also. So in the next class, we will learn why the lead 2 has a taller QRS complex and why lead 1 has smaller QRS complex in the next class. So that's about the bipolar limb leads. Next class we shall learn about the mean QRS axis and its estimation by the bipolar limb leads. So thank you all for patient watching.